Hello. Oh my goodness. Let me check. Okay. Yeah. Well, people who were going to join have probably gone now. So, I was meant to write hello. Yeah. Oh well. Yeah. Guess we'll start from this point. Let's go back. Let's go back to here. Let's shut that down. Let's minimize that. Let's go into here. Let's zoom in so it's kind of viewable. Yeah, that's better. We'll go into code. We'll go into, I think it's Haskell learning. Yeah, and I think I stuck it inside here. Actually, this will do. And then we'll just quickly start that up. Let me just resize this so it fits. Just about. Yeah, that'll do. Cool. Shut that one down, and then we'll do Doom. Sync, isn't it? I gotta do my little syncy thing. Syncy with my Doom. Cool, and then we'll open Emacs. All this I already had ready. I thought, okay, this is going to be the stream. I'm going to get stuff and it's going to work from the get-go. How wrong I was. Basically. Just doesn't, I don't know what happens. It's like the mic just goes on and off, on and off. But it's from within the application, I think. Let me just look on the side. Yeah, it kind of seems that way. I don't know. Kind of giving up, to be fair. There we go. Let's pop that in there. There we go. That's me. As per usual. Okay. Let's get rid of that. So we want to go. We want to go inside source, and we've got journey, which is the name of our file, and journey also referred to this. There we go. So we were going through. Oh, is that monad? Okay, so we were going through this series. Let me. Oh, didn't want a new window, but anyway, we were going through this series and we'd gotten to number 3. Yeah, part 3. So that's what we're on. And part 3 is monads. And then how far did we get in monads? Let's have a little look. So we did here maybe funk. This, yeah, I guess here. That looks like the monads, doesn't it? Yeah. So let's see where that is in here. Class monad. Yeah, so we did those. Kept going. Instant monad. Do we do an instant? Oh no, yeah, we explained that. We spoke through that. What else was there? Let me just close this one. There we go. So things don't go mental in the background. Whoa! This was a good one. If you're, this one was how to do a mailing list scraper. I'll pop that in the chat as well. That was an interesting one. I was watching it the other day, or finishing watching it. So where are we? Let's have a look. So I guess, had we done that? Run maybe funks. Yes. So we did a do. Blah blah blah, and then oh yes, I kind of went quite in depth, didn't I? If we look at here, yeah, that's pretty cool. Yeah, I'm just going to turn that down because it's too loud in my ear. So okay, so let's go back here and let's have a look. Or oh, I know what I did last time. I kind of did side by side, didn't I? We can do a bit of that. Don't need that much room on this one, can we? So I can just do a bit of like this. Yeah, that's kind of cool. That works, doesn't it? I think so, yeah. Okay, now, next. So it's saying, that's nice, which is here. Not so nice. What's the not so nice? So maybe input. Oh, okay, yeah. It's just saying that it's a lot easier when you're doing a do block to take that value out and add a 2 to the value to then pass it on to maybe func2. But if you do it with the actual just the binds, because essentially that's the same as this, the problem being is you have to create this lambda here, so this like a function awaiting another function to try and get hold of the I, which is this value here. So yeah, that's the problem with doing it that way, but never mind. Okay, so the gains are even more obvious if we want to use multiple previous results. Using bind, we would have to continually accumulate arguments in anonymous functions. One note about do notation: we never use the left arrow to unwrap the final operator in the do blocks. So what that means is you can't just like that. That won't work if you try and if I just reload that. So then we get some sort of an error message, because that's definitely an error. And there we go. Yeah, so it's saying the last statement in a do block cannot be an expression. Yes, you can't just go, oh, return this f. You'd have to be explicit. You'd have to sort of oh, actually I can just do it like this, except f won't be. What is f at the moment? Let's have a look. So we'll use the underscore, which is a type hole, and it's showing us a bunch of stuff. So if I go on here, I'll make this a little bit bigger. F at that point is a float. Yeah, okay, so we're not going to get anywhere near getting back an int, but we know that maybe func3, wherever it is here, that takes a float and that returns this. Oops, let me just hide that for a little moment. Yeah, so maybe func3 takes a float and that would return a maybe of a list of ints. From this point, you see, we'd have to just make that float, and then we could just literally just return f there. But we're not going to do that, so we'll do it like this. Cool. Either monad, which I assume is the next one. So here I probably went more in depth on all this. Yeah, that looks probably what I did. Okay. So either monad. Cool. So now let's examine the either monad, which is quite similar to the maybe monad. Here the definition instance is this. So let's copy it out. So we'll do an instance of a monad, and we're going to do either. Well, actually, this is. I'm going to have to. Yeah, I just won't save it. It won't work because obviously this is already exposed to me. So when you return R, which is, if we look further up, the two things that monad want is a. Where are they? Does it show us further up here? So instances of monad. Where does it tell us? Maybe monad. I thought it was a little bit further up. Well, anyway, we did make our own though, didn't we? Here. Yeah, so the two instances are return and the bind. So hold on, let me just go back to where we were. Burp, 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 burp. Yeah, so what it expects is a return definition and then a bind definition. So we know that maybe, because we create our own maybe further up there, basically that expects a just and a nothing. So if we pass it a nothing and we bind it, it doesn't matter, because the way we're going to tell when we use a maybe, the way we're going to use it is by saying, well, I don't care, I'm just going to return a nothing. I've put the ticks here because this is where we created our own version. And then if we do a just of a, then at that point we'd have an f, which is a function, okay, and then the way that would work is we just do f and apply to a. So if we look at quickly, will it show us incorrect indentation? Oh yeah. Okay, hold on. let me just comment this stuff out. Oops. Go like that. Okay. Let's go back here. Yeah, here we go. And so I've just put another hole to work out what's going on. So the hole found was A, and if we look at F, it takes an A and it returns us a maybe B. And then the hole it expects is an A, and then if I was to get rid of the F, then the hole is a maybe B, so it expects this side to be a maybe B. So then we give the F, which the F is an A to maybe B, and then at that point we're like, oh okay, well I need to return, if you look at the F, it takes an A and returns a maybe B. Well, we know the original hole was a maybe B, so to get that right, then we're just gonna pass the A. Boom. And that's how the monad works. So when we do here, which is like where we're doing the bind, or where was the other example? Here. So this is all, so if you look, this is a function, that's why it's an F. That's a function expecting a value and wrapped around the monad. Okay. And so for that reasoning, let's carry on with the either monad. So return R, and this is the same as so it's the same as maybe, but what we're doing is instead of just returning a nothing, we're able to return we're able to handle the left. So either let's have a quick look. Let's go here. Let's go here. Let's go here. Hugel. Always use Hugel. We'll look for either. Where is it? There, either. There we go. When it comes up, there we go. Its constructors of either is left A. So actually, should we just quickly have a look like this? What we'll do. We'll find either. Either. How's it declared? There it is. Is it? Yeah. There it is. Boom. Okay, so we'll make all our own. I mean, I actually knew that. I don't know why I just went to look, but I think it's more the case of, get used to how you get around and find things. So anything on the right hand side here, it says source. You can click on it and it'll take you straight to the source. And then from there, these are actually clickable. So you can actually click and you see how it jumped. So say we were to press, well, it wouldn't work in EQ, but anything within this file, it will jump to that location. So yeah, so I just jumped and then I looked at the data type. So for us, I've just put little ticks there to demonstrate that there, and then we'll put a tick here. Okay, and we'll put an up like that. Cool. So that's that one. So we've got our own either. So at least now we can do this. Okay, so when we return something, then we want it to be a right. So it can never be a left, because if we think about it, the left is our error, so the left is our nothing. So if you look at the return here, that return is basically saying it's a just of A. Okay, so that's like our happy path, and that's our sad path. So if we look here, the right is our happy path, and now we're going to do the sad path because we're sad. So left, left L. Yeah, so that's for left, and then we're going to declare the bind, and then let's do a little bit of this, because sometimes I find it's a little bit easier. There we go. A little bit easier to read. Okay, and that will return the L, and then let's do I'll explain it in a second. I'll just write it out and then yep, and then at that point we care about the function. We'll do this. Boop. And then right. Oh no, why am I doing right? It's just FR, isn't it? Then you'd have to make an applicative because monads aren't. Come on, let's just do it. So instance applicative Is it just either a where? What's happened? Oh, and then it wants a functor. We're gonna go the whole hog. Let's do it. This is good practice. Practice. Functor. Either a. Oops. Where? Okay. So what do we want for functor? We want an fmap. Fmap, a function, and then it'd be our either. So it'd be the first would be a left. Yeah. And that would equal. Let's have some help. What does it expect? Here it wants found a hole. It should be either A, B, where B is a rigid type. Okay, so let's have a look. So here, actually, in reality, so if we do left, I'm pretty sure. Oops. So look if it's still found an A. Yeah. Cool, that's right. So it's much like a maybe. The left we don't care about. And then if we do right, A. And that return a right. Or does it return right? Let's have a look. Return either A, B, yeah. So right. F, A. There we go. What I'll do is I'll do another little type hole here to demonstrate that. What's my warnings? Shadows age. Where is it? Get rid of these warnings. Import. Okay, it's not used. So that's one warning gone. Age. I have a tick. Where is age used in here? It's up here. Okay, happy. Another binding of age. Tick tick. I mean, yeah, it's a bit silly this one. I can turn it off, but I just haven't. So warning, where are we? Here we are. Cool, so we're at the right place now. So let's have a little look. So we're making an instance for functor. So this, actually I should probably, yeah, if this isn't like super clear, I guess it should be clear if you're watching this level, but I'll explain just in case it isn't. So what we're doing is we're saying, well, anytime you use this type either, what we want the ability to is show how that, oh look at all these gaps, it's crazy. We want to be able to show how that acts when it works with a functor. And a functor, generally like the easiest functor you can think of would be this. Yeah, so the functor is actually the list, and the inputs of it are the A's. So when we look at here, this is our functor, and then so you see we're saying, well, that's like a functor's like a wrapper essentially, and in this instance we're saying, okay, well, how are we gonna you know, how does the functor has its own classes, and for it would be fmap, and that's one of them. And then what we're doing is saying, okay, well, how is functor, our fmap, sorry, gonna act when we use it against our own custom either? So we've got our own custom either, and we're saying, okay, well, if you pass fmap a left of A, I'm just going to return you a left of A, and that's the way I'm going to work. And if you pass it a right, I always think like left, wrong, right, right. Logical logic. And it's very similar, you see, it's similar to maybe. Well, that's in the monad, but yeah, it's similar to maybe. The maybe is just and nothing, except the just returns a value and nothing is just nothing. But here we're able to pass on that value of failure, which in our case is A. So we're looking back at the hole. So I've created a hole here just to get an idea of what it is. And at that point it's saying it wants a B. And then if we look at our functions, we've got an A. You know, they're not like, because at this point they're not assigned to any sort of real you know, like types per se, that we're using like type synonyms in a way. And then look, so we've got A1, so we've got an A which is an A1, so that's referring to this A here, and we've got an F which is an A1 to B, and then we want that hole to be we want this hole that's missing, it's the compiler's telling us that needs to be a B. So well, okay, so you just want an FA, surely. Yeah, that's right. So this is what is really important, and what I found, I don't know, it took me too long to discover how important type holes are. They're really, then you're, instead of like getting it wrong and waiting for a compile error, you can just literally use it. It'll show you what's in scope, what their values are, and it's just like so useful. Applicative, is it? Oh, I forgot what the instances are. Hold on, it should tell me. Next bit, we've got apply, we've got pure. Okay, pure. Let's do pure. I don't actually remember, so let's do it. Actually, it'll only work on right. A equals, what's it telling us? Found, what's not happy here? Found hole either A1, couldn't match A1, defined, used A, so look. So, pure, have I either, right, oh, so it's, yeah, so it's literally, oh, of course, no, yes, I don't want to destructure it, do I? Aha, thank you. Tolbowov. Yeah, totally forgot. So at this point, if we look at the type hole, yeah, so it's either pure A1. Oh yeah. Yeah. We're like, there's a weird delay. I have to look and sort of, oh yeah, you just caught it, thanks. Yeah, it's a bit annoying, it's like a 10-second delay. So you have to predict what I'm going to say in 10 seconds time. And then it's impossible for either underscore be right. To write a funct instance for either. On the, I don't know what you mean when you lay it out like that. I'm not sure. Oh, okay, new types, yeah. Oh, yeah, no. Let me just, what was I going to do? I'm trying to remember how to do applicative of either, which is good, isn't it? Okay, let's try and remember. I was like, oh, this is easy. I've done it loads of times. I'd probably, to be honest, the monad, which I've done, is easier. So here, what does it want? So does it want a function? It wants an either. So oh yeah, I've got to wrap it, haven't I? Boop, there we go. So yeah, pure is literally just wraps our A in our either, and then for our scenario, we know that our left is like the nothing, so we can't return a left. It always has to be a right. There is more of a reasoning to that, but I'm not going into it today because it's pretty. And then we want apply. Whoa, hello. Cool. So we're going to apply. We want to apply two of them, don't we? No. Here we go. See what this comes up with. Either A, B, cool, thanks. And then we can't just ignore them. Try and remember which way around it is. Okay, so we'll go right, A, cool. Hold on, what am I? I've totally forgotten there. Show me apply. Okay, you're not going to show me apply. We'll go over here. We'll get apply. We'll get it from here. Thank you. I've just got to remember the type of apply. Woo. Cool, there we go. So, applicative. So what I'm doing now, if I zoom in, where is it? Hello? Yeah. So, FA, so that's our function, it's to the left, and then our values to the right. Yeah, so that would be an F. And then on the right hand side, what are we doing on the right hand side? So it's type a whole of either. Yeah, so that's cool. And so let's do a right. Yeah. And then what does it want? The B. Let's have a look at what we've got available. We've got an F and an A. F, which is an either. And we've got an A, which is an A1. So at this point, we're still, the F is still wrapped around. Oh, it's the right hand side of the either, isn't it? Ooh. So we want the E. So the F is an either AB. So it's not a case of FA at that point. Try and remember. I'm not going to cheat, but I want to. But I'm going to try and remember. So I've got a feeling that you have to pass. So this has got nothing to do with what we're trying to learn, but might as well just do it. It's for my benefit. Sorry. Is it? For some reason I feel it's like it's a lambda, but I don't know if I'm thinking correctly. What am I looking at? So A1 either A. Do I bind it again? Oh, feels like I do. I want to get to the right value of either, which is R. Not bind, apply. Ooh, I gotta try and remember. Okay, well, let's play with F. See how it complains then. Yeah, so it's not expected, so it wants. Yeah, that's fine. Because F, it's saying that F is applied to one argument, but its type is blah blah blah. Whoa, don't plus it. Am I going totally the wrong way now? I've totally forgotten. Whoa. FA can either. Oh, blimey. So it is a. I didn't even read the type. Is it? Quick match either. Oh no. I'm gonna have to cheat. I've totally forgotten. Where am I going to look? Applicative of either. I'm going to kick myself when I see what it is. Applicative. That's not the right one. Yes, it was. Cool. Applicative. Where's either? Oh yeah. Oh. Well, where are you then? Or do I have to look on either? I have to look on either, don't I? Oh, I'm having a. This always happens. If things can't start properly. No, it should be on applicative. Oh, maybe it is here. Oh, yeah. When things don't go right, yeah, i.e. the microphone not starting when I started, then the pain just extends and gets worse and worse and worse, which is basically what's happening to me today. So we'll find. There we go. So what did I do wrong? Don't. What? What am I? Huh? Hold on. I am doing so. Oh. Oh yes, yeah, I did do it totally wrong. I thought I did it wrong. Well, wasn't gonna get anywhere there, was I? So we've got the pure. Yeah, so we can do ignore the A because basically we're just passing it from the left to right, aren't we? Yep. So it's that one, and then the next one we want to left it. Oh, like that, and then we're gonna apply like this. Yeah, so it doesn't matter about that case because left is always going to return because you can't apply to lefts. And here, this is where I got it the wrong way around. It's going to be right F and then the R. Yep, that's like that. So I can make the monad one, but forgot how to do the applicative one. So that's good fun. How would it actually? Let's have a look what it'd return. So here it's saying couldn't matrix. Yeah, okay. Well, oh, why is it not? Oh yes, of course it can't. It's the wrong right. Ah, there we go. So it's saying it's an either AB, and then how do you get into the value? Because here it'll say the R. Yeah, this is where I was trying to do a lambda. Yeah, so we want to get into the either. So we want the right hand side. And then if you look at the F takes an A1 and then it returns a B. And we want to get to the right hand side. And then we know because we did the functor, if we F map over the either of right, it'll return us to the right hand side. So basically we want to F map the F and then the R. Boom. Okay. I can't believe I forgot that. Yep, sorry. But, you know, there's no shame. Can't remember all by heart. Okay, so that's that one. So now we've got our own either. So we've got our functor, applicative, and our monad. Cool. Let's go here. Okay, so the either monad. So whereas the maybe either succeeds with a value or fails, the either monad attaches information to failures. Just like maybe. It wraps values in its... oh my goodness. I had a prime opportunity to do this. There we go. That's it. That's me trying to remember the applicative for either. There you go. It's gone again. Right. I'm trying to use that as well. Actually, I shouldn't want to use that as much as possible because that's normally when I'm doing a bit of a boo-boo. But there we go. That was me this time. Okay, so just like maybe it wraps a value in context successfully, the monadic behavior also combines operations by short-circuiting on the first value. Let's see how we can use this to make a code from above more clear or clearer. So what was that? Oh, it's maybe func. Let's have a look what it's doing because I probably won't. So maybe func takes a string, either string or an integer. I guess we've already got maybe funcs. Yeah, we do. That's from the last stream. So let's quickly make yeah. Okay, we'll just what shall we do? We'll do one with a tick. I think we've already got a tick, but oh, you know what? For instead of just watching me type stuff, there we go. And then I'm going to give him. I've got a feeling we've already got a tick, but we might not. So no, we don't. We're fine. Maybe. Let's reload that. Cool. So that's reloading, and then we've got 1, 2, 3. Oh, actually, yeah. It'll be easy if I just hold on. Is this? Oh yeah, and then before it gave a failure. Yeah. Okay, let's copy some more of these. Except I'm missing 2. Except these Oh yeah, it's gonna complain about a few things. Firstly, that, and then also over here. Don't give me a tick. And then let's go to the end. Let's go here, and it doubles. Thank you. And we'll do a bit more of that. And I'm missing number 2. Yeah, it's easier to, because if you just watch me typing in, it's a little bit more boring. What I'll do actually is find these and do a bit of that. Oh, I didn't find it. More of that? Okay, so you're going to replace one side, but that's okay. And then we'll replace the other side here. Yeah, okay. Whoa. Okay, well at least that. Okay, so at least that's got going. So what we're doing, previously we did it with a maybe. And then what we did is instead of passing a left, we passed along a right. Sorry, a nothing. So this would have been nothing, and this would have been just its length. So it's doing the same. So this is taking a string, and if it's not an empty string, it's going to this pattern match, and it's going to go return a right and the length of the string. Okay, so it's going to return us a right of int, and at this point, this function 2 takes in an int, and then it will do either a string or a float. So again, very much, well, first we do an if. So we're doing if I is a modulus of 2 is equal to 0. So this is even, and yeah, if it's even or not. So if it is, then return the error, which is a left with a string inside of it. Otherwise, return the right, and then do from integral 1 times pi. Cool. So that's okay. And then function 2 again, so it takes a float and either a string or a list of int. And very much so if f is higher than 15.0, then return our left. Input. Oh, is it not recognizing that? I mean, you don't need it, do you? That's probably why it's not recognizing it. Yeah. And then right, otherwise right, and then it wraps the floor of f and the seal of f inside of. Actually, I think we might have an error because we did from memory. I think seal. I think it was sealing we had to use. So I guess when that. Yeah, there we go. Oh, hold on. First, they're going to complain because they're matching to the ones above. So we'll quickly change that. Yeah, maybe this as well. Oh, hold on. Duplicate type signatures for run maybe funcs. Why have you... Wow. Okay, so I've written a few of those already. Cool, yeah, there we go. This is what we had last time, the error. I think it's sealing. Yeah, there we go. Cool. So that was the error. Yeah, so, and then this does other stuff. It checks if it's above 15, and if it isn't, then it gives you a list, and the 2 items in the list is a floor f and a ceiling of f. Cool. And how do we put it together when we're... So, oh, we've called it, mate. We could. Why don't they call it either func? Oh, or is it? Never mind. I'm gonna. You know what? Instead of like, I mean, that makes more sense because it's not really a maybe func anymore, is it? Because I think what it's trying to demonstrate, which look at that, either the func, either runs runk. Cool. So I think the demonstration, what it's trying to say is if at any of these points, much like the nothing before, so if any of these fail at any point, so if say the first one returns, then it will return you, the whole function will return you nothing. It will kind of like stop there if it stops there, but here it's going to stop, so then you have a better idea as to which function might have broke due to the error that you're getting back. But in in our case we're just using a string. I think that's the idea behind it. So what we'll do is we'll close that. We'll do a bit of this. I'm just opening the REPL just so we can play with it. Data list. Oh, I've got to press no loads of times. No. Okay, that's fine. It's happy now. And we're going to load this file, which is journey, I think I called it. Yep. Okay, that's fine. And then we're going to run. Is it there? Yes. Oh, not maybe. Run either. There we go. So if we run it with an empty string. Cool. So that empty string is going to hit our first case, which is here, and it's going to return us. Let me just. Wow, look at that. This is handy, but not right now. So it's going to be a left, and it's going to be a string. So that's why it returns us. So if we look, that failed there. That was the first. If we look here, right on that one, it was like, well, no, I'm going to return you a left, and then the rest just passes it along and craps out. Next. I don't know, why am I getting nothing? Oh, okay, I'm going here. Run maybe funks. Yeah. Left, and then if we do a high, let's do that. Run either funks with high. Was it exclamation mark? Or was it just high? Yeah, high. So the length cannot be even. Yeah, that makes sense. So it doesn't want it wants to be an odd length. And then what did it want at high there? Okay. High there. The float is too large. Cool. And then so then if we do run either not inside strings funks, and what was the option? It is just hit. Yeah, boom, there we go. So at that point, because we've checked, well, we've done all the three checks. So the first check is it empty? No. The second one was is it even? And then by that point is this valuation here, is that larger than 15? So I mean, by the looks of things, by the looks of things, I don't think it will get much. Oh, yeah. So you can't even. Yeah, so you can only literally 3. That's all you can pass it. Something that's a string that's 3 long. So notice that we parameterize the either monad by the error type. If we have maybe either custom error float, yeah, so we could, so we've done here, if we look, we've just done string, and it's saying that, well, we could literally at that point now we could have a custom error, and then wherever the call would be, so we could say this is well, wherever the run either would be the call, we could do a case match over that and look at our custom error, and we could return specific types of error for each one, and then we'd you know, so we could have like this. Whoops. Whoops, whoop, 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 whoop. So we could have data, oh, what do they call it? Custom. And it could literally just be, yeah, we could literally go, I don't know, what is it? Even. You know, is empty. Oh, is empty. Even. Or not even, blah blah blah, like that. And then when we were to return it in here, and then at each stage here we just return that type, and then when it came to the source of where this is being called, then we could case over its results, you know, so like case of its results, and then we'd be able to we'd be able to handle the errors differently. So rather than when you do a maybe, you know, you're only going to go yes or no. That's it. That's going to be the end of it. But here, it just gives you that little bit of extra flexibility using a neither as you know, wherever the call site is going to be, you're going to be able to handle that, and then you're going to be able to also dictate what type of error you got. So yeah, that's what it's saying. Oh, excuse me. This function is different to monad now. It won't be quite as simple to combine this with our other functions. If you're curious how we might do this, check out this answer on Quora. Quora. What's the answer? Oh my goodness. What are practical uses for bifunctor in Haskell? Yeah. Another day. Right, we'll move on. The IO monad is perhaps the most important monad in Haskell. It is also one of the hardest monads to understand starting out. Yeah, I guess it is. Yeah, it actually implements. Its actual implementation is a bit too intricate to discuss when first learning monads, so we'll learn by example. Best way, trial and error. That's all I've ever done. So the IO monad wraps computation in the following context. This computation can read information from our write information to the terminal, file system, operating system. So what it's saying is an IO monad is like hitting the external world, because we know with Haskell, the idea, in brackets, is that our functions are all pure and they don't deal, they shouldn't have any side effects. And then what Haskell does, it tries to, anything that's going on, so like grab a file or read something from the a terminal input, that's an external output that it can't predict what it's going to be, so that's a side effect essentially. So what it tries to do is to, anytime there's sort of an external interaction, it gets wrapped in this IO monad. Okay, maybe don't explain a little bit more. So if you want to use user input, print a message, so you can go the other way, sorry. It's also what you take in and also what you can give out to the world. So create a file or something like that. Oh, there you go. These are side effects. We cannot perform them in the pure Haskell code. There we go. So we're pure. We're not. Yeah. So the IO monad, in essence, is it's kind of like giving you a security. It's almost like someone going to jail, and then you're wrapping them. Oh no, Haskell isn't a jail. Okay, a child going into a play area, and then you're not sure if that child's is full of diseases. So you put them in a bubble, like the bubble kid. Is it bubble kid? Let's have a look. Bubble, was it bubble guy? Was it bubble kid or bubble guy? What's the name of the movie? Maybe it's Bubble Guy. There! Is that it? No. Okay, well, it's a really weird movie about a kid in a bubble. And that's basically our side effects. We wrap them. I'm not going to find it. Keep going. So the most important job of pretty much any computer program is interact with the outside world in some way. Yeah, because if we just kept stuff pure and just never did anything, it'd just be like the philosophy is it's not a very nice philosophy, but is the cat dead inside the box? Well, you don't know until you've opened it. Beep, beep, beep. We could use another one that is a cat alive? That's a better way of seeing it, rather than is a cat dead. So for this reason, the root of all executable Haskell code is a function called main, and its type is IO of unit, which makes sense. So at whatever we do inside the actual program, there has to be a point where it's going to interact with the world, and that's usually the main. So everything sort of filters down to there. So every program starts in the IO monad. Yeah, so everything in Haskell, if you're going to, like here we're not, because we're just messing within Haskell. But as soon as we want to do other stuff, which I'm sure we're about to, yep, there it is, then we have to have the IO monad at some point. So every program starts with IO monad. From here, you can get any inputs you need, call into relative pure code with the inputs, and then output the results in the same way. The reverse does not work. You cannot call into an IO code from pure code. You cannot from pure code. Okay, yeah. The same way you can call into maybe functions from pure code. Okay. Let's look at a simple program showing a few of the basics. IO functions. We'll use do notation. Yes, which is like what we've been doing here on this side, to illustrate the similarities to other monads we've discussed. We list the types of each IO function for clarity. Cool. So let's quickly do some of that. Except I don't think it might not run from my REPL that's in there, but we'll try it. I'm pretty sure I've done this in the past and it just hasn't worked. So this is just a... Okay, it's wanting us to comment out, is it? Okay. Oh, is it just telling us what the type of get line is? Yeah. Okay, well, we can see that. Hold on, let's bring that down a little bit. Bring it down. So input. And let's use the function get line. Cool. Well, I've got this, so is it going to show me? Can you show me? Okay, I'll show us in a minute. I'll get you the type. Well, actually, you can see it on the right hand side. So let uppercased equals. What is it doing here? Oh, okay. Is this like? Okay. Well, I mean, it's probably just gonna. Yeah. Okay. Input. And then at the end of that, don't do that. And then we're going to return, we're going to print. It's not finding it. Okay. Especially now it's got 3. Cool. Let's have a look. It's rebuilding. Goes a little bit funky, the Haskell language server sometimes. Well, for me especially, it seems. It's a bit like me starting my streams as well. Cool, so it doesn't know it, but we can bring it. So we can import it from, was it data.char? Yeah, there we go. Cool, so we imported it. Oh yeah, that's another cool feature, isn't it? So if we look at the top, there, see? It's done it for me. Yeah, so that's like another little cool feature. And on mine is space CA, and then that shows me my information. Okay, so what's happening? Let's have a look at, there we go, we can see the stuff now. If you look in the top right, get line is an IO of string. I'm on 5 something, is it 0.5 I think? It's the latest one, I'm pretty sure. Let's have a look. I can find out. How can I find out? Here we go. Do this. I've just got to go into my next instance, and then I guess it's just. Oh, automatic half? Is there? No. I don't believe you. I don't know why I said I don't believe you. Of course I believe you. Is it version? Should we guess? Ah, 4. Oh, I thought I was on 5 on this one. Maybe not on this specific one. I'm not on 5, which is a shame. No, is the latest 5 or is it 4? I'm gonna go look. Especially if I press the right keys. Haskell. There. Yeah, I thought it was 5. Yeah, there we go. See, that's on my hot. I'm always on this. I don't have it on here. I do have it somewhere else. It's because of my. It's because I started this a while ago, I think. Let me see. Go to the right one, please. And let's do some of this. So look what I've set up with my Nix file. I think it's inside my default. Potentially. If it opens. Or if it just crashes everything. Oh, yeah. So I'm using niv. And when I use niv, I don't think I updated it. Yeah, if we look at the source JSON. Whoa, what is it grabbing? It's grabbing Oh, it's grabbing from Nick's tooling, which is like a repo that I copied off Vlad, but made my own version. But yeah, I didn't upgrade to 5. I think there was a reason why I couldn't do that with Niv for some reason. And then I've moved over to just doing it without Niv. And then I've got 5.0, but not in this one. No, I don't care. I don't mind derailing. It's probably not going to be that. I could do it in seconds, I think, because I have it right here. I think I have it right here. Let's have a look. Let's open this one. Is that it opened? Yeah, it is. No, maybe it's in my shell. Yeah, there we go. So in my shell, I'm package, and then yeah, when I bring it in, because I've pinned it, then I can bring it there. And at that point in time when I pinned it, it was a 5.0. So let's copy it. Yeah, let's do it. Because there's not a lot of files, so no, don't create. I've got to remember what a copy is. Copy YF, and then we're going to go into there. We're going to go into learn there. Is it going to override? Copied. Okay, thanks. Did it copy or did it just steal it? No. Yeah, that might be why. Copy 1. We'll rename that to be shell. If that makes sense. And then I'll get rid of default next. Yeah, kill it. Why not? And then we'll go back up here. Where's default? FY. Didn't press the right thing. F. No, definitely didn't press the right thing. F. Y. Was it YF? YF. Yeah, it might be right. Learn. Yeah, in there. Cool. So there's that. And then what I can get rid of is, I think stuff in here. Yeah, I can get rid of that. Okay, and then what I'll need to do is whilst I'm here. Oh, will it work from here? Because it needs a fakey.nix. Yeah, this is a bit like a weird one. Right, okay, so what I'll do, first thing, let's quit. Like that. And then we've got something here. So, is it nix? Hold on. Cabal to nix? Does that exist? Yes, it does. Wicked. So, Emacs. Yeah, I know it died. It's fine. So, cabal to nix. And it was, I think it's just dot, isn't it? And then we called it, oh, what was the name of the file? Fakey. Fakey, like skating. Was it .nix? Pretty sure. Is there a fakey now? Fakey nix. Yeah. Okay, so let's exit. And let's nix shell back in. And fingers crossed. It might have to load. Yeah, so it's just downloading the... Because I've done, what are you not happy about? Failed. HTML doesn't exist in its directory. Oh no, why are you not happy? Hold on. Oh, well it's gone in though, so is it just a warning? It's just a warning. Yeah, we don't care about warnings. And then I think I can just do, then from here I can just do, yeah, like that. Yay, there we go, on 5. That wasn't too long, was it? I mean, this is when Nix is nice, which is quite rare for me. Normally I'm waiting like 6 hours for a version of GHC to compile. Yeah, so hold on though. Okay, cool, I'm on the right GHC as well. Just checking that I was on the right version of GHC, because otherwise that's like, yeah, game over then. We're going back. And then this is another trick I have to do. I have to sync stuff in Doom, because then it puts the right values in the environment variables, and then I'm able to work with it nicely. There we go. So this is back. Let's make it bigger, and then I'm gonna have to up the font at some point. How big is that? So left screen. There we go. Is that, yeah, that looks alright, doesn't it? Maybe one more. Oh, I've gone for it. One more. You can put your glasses away. Source, journey, and then we'll see what happens. I might have to delete. Oh no! Why? Why have you not been happy? Oh, I know why. I know why. I thought this might happen. I'll remove the dist. There we go. And then just for. Am I in the right place? Yes, I am. Yeah, I'll do that again just in case. And then hopefully, fingers crossed. I'll do. Yeah, I'll build. Except there might be an error because we left it. Oh, what do you mean it's conflicts? Don't have conflicts. We don't want conflicts. Who wants conflicts? Certainly not me. Am I like on a weird... okay, well... We can fix this. It's okay. You've derailed me. It's my own fault though. I listened. I'm purely to blame. I should have gone, meh. I don't care about 5.0. But I had it, and then I felt like I was going to gloat and show off. But it didn't happen, did it? I basically failed. So look what's wrong. Oh, is it because of the bait? Okay. Look at all this stuff. Why is it all this stuff? What am I doing? Oh, I'm a bit... Is that what it was complaining about? Tool is always... Yeah, it's always... I think it's the base, isn't it? It's rejecting the base. So if I just like... Don't worry about what version of base we're using. Just go... You work it out. Maybe a little bit happier? Is there some other stuff? There's like some other stuff down here. But I don't think... I think that's the only base there is left. Base in your face. Yep, that one. So I reckon... I think we might be in a good place here. Except... Oh yeah, I've got to do... what am I going to do? I'll do some of that. Because I don't remember which... Nick shell. Nick's shell. There's a guy called Nick. Well, it could be Nicola. There's a gal called Nick. And she has a shell. See, she sells... Okay, stop. What am I doing? Oh yeah. Dist. There we go. And then we're going to do... okay. Bring back my memory. Build? Yeah, not run. This time, fingers crossed, it's happy, it's doing something, and everybody's a winner. So I'm going to do Doom sync for good luck. That's that. I'm going to quit out of Doom again. I think I'm not one of those people that goes outside the door and goes, have I turned the oven off? But I just did it with my Emacs. I guess it's a bit easier to check there, isn't it? Okay. Except I've got 2 Emacs versions up now. Well, you can only see one, but I do. Where is it? There it is. No, I've only got one. So what's it got? Oh, okay. It was just lower. It's just lying to me. Here we go. Here we go. Cool. We'll probably like... I'll go maybe a little bit like that. Something like that. Doesn't matter, does it? There we go. Yeah. Come on then. Come on, Haskell language server. I believe in you. Yes, it's starting. That's a good step. And it's worked. What were we going to try? I forgot. Hold on. Where was it? Hole filling. Yes. Let's go. Filling holes. Okay. Let's have a... I mean... This is going to be a prime example, surely. Let's have a look. What's it doing? Replace with. Oh, okay. Well, with F. Sweet. Done it. That's worth it. No, still, that's good. Yeah, I forgot that. Let's do it again. That is cool. I guess it'll be... Oh, hold on. Let's do it something potentially... Try this. Uh-oh. Uh-oh. What am I going to try? I'm awaiting this try. Hold on. Does this... Let's... Whilst I'm waiting... we'll open up this. And... Don't get rid of that. No. 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 Here we go. And then if we load our file... journey? Yeah. There we go. And then I think this is not going to work. Maybe it will. Oh, it did work. Sweet. Okay, okay. Try this. So type cont. Yeah, okay. I'll grab that. Grab it. I'm ready to be amazed. Oh, what do you mean you held them? Allow. Don't hold a message. I've never seen that before. Okay, so we got our type cont. Let's have a look. Oh, like continuity. R-A-A-A-R-R-R. Yeah. And then we're going to join cont. Go down. Like this. Do I put... Don't count. What is it? Is this what... I think that's what we're trying to do. Replace with... No, we don't replace with that. Don't replace with that. Attempt to fill hole. Where is it? Attempt. No. Oh my god. I didn't see that one. I did not see that one. What's... Oh. Okay, Voodoo. Ready? Go. No way. That's not right. What is going on? What sort of magic is this? Right. We can stop the stream. We don't need to learn Haskell anymore. We've got... All you need to do is just type. That's it. Just learn types. Quit. Quit, you know. Don't go like me and, you know, slipping on creating instances for functors. Sorry, for applicative. What are you doing? Just wasting your time. Wow, that's impressive. That is really impressive. Yeah. What, just from the types? Yeah, just no, everything types. Just do type programming. Actually, we need to, for it to work out the types as well. Basically, we need a plugin. I mean, if we're going this way, let's just write our program from speech. We could just tell it what to do. That's what I've been after for years. You know, that's the thing, isn't it? It's a frustrating thing. You're there and you're going, okay, I know exactly what I want you to do, but you ain't bloody doing it. Under development. Yeah, I've seen the progress. I didn't realise it was that good. I saw the progress, but I haven't tried it out. But that's very, yeah, that's really impressive. That's good. Wow. I just did that. Look at all that. Just worked it out from the types of cont. I'm going to do it again. It's like a new toy. Attempt to fill hole. I mean, yeah. It's not bad already, is it? I mean, even the fact that we've got just the ability to do imports and, you know, like even like this with the docs. When I go here and I get the docs above, just it gives me the types and things like that. Just get line, yeah, that's a little bit better. See, well, the docs that have got, you know, docs in them. Wink. Yeah, wicked. That's impressive. Well, thank you very much. Yeah, I like it. Right. Don't know what I was doing. Wasn't it, whatever we're going to do, it's not going to be as impressive as that, is it? But we'll try. Yeah, 5.0. So we were here. Okay. I basically ran that and it worked, which was another impressive thing. I mean, we're on the roll now. This is just getting better and better. What's happening? Not expecting that. Oh yeah, so this was the other thing I was sort of I'm going to keep that there. Further down. But I'm going to keep it. Because I'm not getting rid of that. I don't know who I'm going to show. I'm going to show someone. Oh, I've kind of, yeah, we've shown the stream, I guess. People might watch the replay. or I'll show my wife. She'll be impressed. She'll be like, yeah, whatever. Bunch of words. Oh, what have I done here? What do you mean? I don't want to go there. I want to go here. Yeah. So we're going to run this, and you can see it's an IO. So where's the IO? Let's go main. So at this point, we're in the monad, and we can still do the do, and it's saying get line, which is not with a capital I. And this is what it's doing here. So we can type in, well, that's what I give back, and I press enter, and then this time around it breaks, which is cool, isn't it? So it's a one time only. I think the whole thing's frozen. It's a pretty good feature, that, isn't it? It was too impressed by the type hole filling. I did say that, like, I wasn't sure this would work, and it clearly didn't, did it? Just died. But we got to see type holes, so that's more impressive. We have to shut it down, I guess, which is like this. There we go. Emacs, back we go. Well, we saw the result with the other one. It returned us a hello in a string. Yeah, that's pretty much. Oh, I'm getting good at this. Journey. Why does it take it down here? Let's take it to the bottom. Take it to the bottom. Okay. Oh, it still got it. Thanks. That's cool. I shan't run it again though. Oh, I was going to do a bit of this, wasn't I? I think. No. I want some of this one. I want some of this one. Here we go. We'll move that to the left a little bit. Okay, we're back to normal. Whey. Oh, it was worth going to. I think it was worth that interlude going off to. I'm still impressed by this. I might leave it in a 4 light. So that's an impressive scenario. So we can once again each line of our program use. Anyway, has type. Okay, so we. Oh, that's my fault. Not badly spelled. I just can't read words. So we see once again each line of our program has a type IO. A let statement can occur in any monad. Yeah. So we could just. So for us, we didn't do the data.child blah blah blah. We just actually. This is cool, but look, you can also just turn it off if you don't want it. Yep. Disabled in this buffer. Sweet. What? Yeah, when you pump up the font, my goodness, it takes up a lot of room down here, doesn't it? Yeah, oh well, can't win them all. Yep, so you can do a let, so here. So basically we've used that input. So if we look at, actually, I'll open that back up. So if we look at, so it's an IO of string, and we know that if we left bind, that grabs string out of the IO. So that, if you look at the input, is a string. I know you can use type holes to tell you what they are, but you can also do it with this docs thing. Kind of automatically does it for you, which is, again, handy, you know, because before you'd have to, oh yeah, why didn't I have this 4 years ago? I think I'd have had like a nice time learning Haskell. Don't complain, you've got it now, that's what counts. Yeah, so we map the input, whatever that might be, and we give it to upper. And because the input, actually we have to map, because the input, if we look at the upper, it's a char to char, and we know that, I think it's probably what I was going through in the other, but a string's obviously a list of chars, so we're mapping over it to go over each one and converting them to uppercase, as we saw the result. And then print, that's another IO, you see, it takes an A and returns to, well, and the A has to be of the constraint of show. Okay, so it's something that has to have a show instance, and then we print it, and that's what we return. So if you look, actually, if we were to do this, why aren't you complaining? Why aren't you complaining? This is the only thing I need to do sometimes, but for the sake of the amount of stuff so if we were to do, let's have a look at the error message it returns. Yeah, so it could return match the type that with IO. So we always need to return, you know, what is in the type at the top of it, which is an IO. So what if we were to do pure? Yeah, it's happy now. Because we know what pure does, don't we? We literally made the... Up here? I don't know, I've got to shut off the docs again. Not like that. Yep, shut them off. Where was it? Anyway, pure just wraps it round, whatever it is. That's the thing, actually, I didn't potentially understand straight away. That once you're inside an IO, and once you've done this, so say it was like a different type of IO, which first instance, so we know this is like, you know, it did the IOs and it grabbed an IO, so it's the same. Once you do one of these, and it's not the same IO as this, then you're done for. That's not a very good explanation. Yeah, sorry about that. But here we're basically saying, well, whatever happens, you know, just pure, which we know at that moment we're in IO, so it's just going to make that into IO. Because if you remember, pure yeah, so pure just returns whatever wrapped. So it wraps our thing. Cool. But we know the print is already in that IO, so we can just do that. And that'll return uppercase. Cool, cool, cool. So we can do that. Just as we could unwrap I in the maybe example to get an int, instead of maybe int, we can use the left arrow or left bind to unwrap the result of getLine of a string. We then manipulate this value using string functions and pass the result to the print function. Yep. This is a simple echo program. It reads a line from the terminal and then prints the line back out in all caps. And in my terminal, it just did it once. And then prints a line back. Yep. Hopefully it will give you a basic understanding of how IO works. We'll get into more details in the next couple of articles. Cool. So, summary. At this point, we should finally have a decent grasp of what monads are, but if they don't make sense yet, don't fret. It took me a few different tries before I really understood them. Yeah, I mean, it's like... Yeah, there's lots of like examples and potentially like blog posts and things like that. And I mean, I guess I kind of literally did how to understand a monad by just doing this. Was, you know, the journey to a monad. And essentially that's it. But when you start off, yeah, it doesn't, I guess it's a little bit, I think monads in use is a lot easier to understand when you actually use it, when you've got it in do, and when you but when you sort of try and think about what's going on underneath, then that's when brains, I mean, even then, you see, look, like, I still couldn't remember applicative, and I've been doing Haskell for like 4 years, so bad times, or good times. Yeah. So that's basically, yeah, so to get to the monads, you once you understand all of these different, which is essentially what we've been doing through this whole set of tutorials. You know, we went with functors, and then we did functor applicative, which is there, and then from there we know we can make monads. So they rely. So you can clearly see here that functor applicative relies on fmap to work, and then from here you have to have an applicative and a functor for monads to work. Yeah. So, but when you see it, I guess when you see it written down like this, it's not too bad. It kind of makes sense. You kind of go, okay, well I know I've got, I mean here we can get rid of the R because, you know, but let's just leave it for clarity. We know if we give return of an R, did I use pure down there? Yeah, return and pure. They basically, you know, are the same thing. Essentially, they do exactly. If you look, they do exactly the same thing. If I was just to rid of that, exactly the same thing. Oh, I like that. I've got a little red thing. Reminds me. No white spaces for me. Yeah. So, what was I saying? I forgot. Yeah. So it's exactly the same thing. And then, if you get, we know that on the right hand side of a monad is a function that's expecting a value. And then if we want to left bind. Sorry, just to bind, what actually happens is, you know, which is further down here, we're grabbing that value out of the right and passing it into F. That's basically all it's doing. But I think the bit that sort of puts people off is potentially, do you have to maybe learn all of this? But really, you just think, it's got a wrapping of some sort, and then there's my value inside. I'm going to pass it into a function that expects that value. Yeah, which isn't, you know, in itself isn't too bad. Cool. I think that's my wife saying we need to have dinner, probably. But I'm going to keep going until I'm kicking off.
Can hear you.
She can hear me. Are you hungry yet?
Yeah.
Yeah?
Always.
Oh, yeah, I'll stop at past then. past, which is in like 9 minutes. Reader, writer monad. Yeah, I'm getting hungry too though. I was meant to start earlier, but obviously technical issues and all that. So this bit is the same as always, I think, from memory. So global variables or lack thereof. So this is kind of like a way, I think this is the beginning of how to handle state inside a application. So in Haskell, our code is generally pure, meaning functions can only interact with arguments passed to them. This effectively means we cannot have global variables. Yep. We can have global expressions, but they are fixed at compile time. If user behavior might change them, we have to wrap them in the IO monad, which means they can't be used from pure code. Okay. So consider this example. Here we want to have an environment container, different parameters as a global variable. However, we might have to load these from a config file or a command line interface. So yeah, like flags from a command line, you know, dash dash, take the milk out, which requires the IO monad. So let's have a look at this. Whenever we oh, is there a load? Oh, go on then. Let's just copy this. We might as well. We've already got a main. I'm going to make it go quiet. Yeah. We'll write another main. Problem being, though, is that it won't... Oh, I can... Oh, yeah. I can try it out in another... I don't have to do it in here, can't I? I've got another REPL I can start up. So, we'll do... and then we've got an environment. Why am I... Look at all these letters I'm pressing and it's none of them are the right one. There it is. I had to look then. Oh yes, so we're going to create a function that's called loadenv. And then stir is going to do a func1. That's going to be another function we need to do. Actually, let's have a look at what... Let's have a look at what happens. We can use... Can we use... Come on, type holes. Not type holes, just Haskell language server. Come on. Come on. I'm going to declare the types for us. Yes. You define that. Thank you. Is that the same? Yes. Oh, A1. Well, we haven't created an environment type yet. And then func1. What are we doing here? Define. Yeah. Stir. Okay, well, he's going to complain because we're clearly not giving it any sort of concrete types here, I should assume. What's the error saying? That's not the error, is it? Thanks. What am I doing? Docs. I don't know what the error is. I'm not going to look at it because there's no point. We're going to give ourselves a type here. A data environment. And that's going to be an environment, and it's going to have params, isn't it? Honestly, I will get used to this keyboard. It's all flashy, but I think it's maybe because like the mic's here or something. Kind of like it a bit. I don't know what's throwing me. Param1 is going to be a string. It's going to be a sting. Param2 is going to be a string, another sting, and if we go here we'll have param3. Yep, let me guess, that's going to be another sting. Spell it right this time. Just that one, thanks. Okay, so we've got that. We want to return load IO. Where's our load IO? It's down here, isn't it? Yes. So that'd be an environment. Cool. And this one takes an environment and returns as an int. Environment and int. Sweet. Look at this. I mean, oh, just yeah. Oh, said we're not going to be able to do any of this stuff because look at load environment. I'm typing it out, but we're not going to be able to run it because of that. But never mind. We could still keep it as this for now, can't we? So what does this do? So it takes the environment and it looks like oh, so it just, yeah, because it's returning a string, isn't it? And then it's going to use another function within it, which is func2. Yeah. So we can do a bit of that. There we go. It's not picked it up, but there's think2. Have we not already called stuff func2? So we're just like passing around the environment. If we look at this, aren't we? There's our env. Well, this is where monad transformers are going to come in handy. Oh, I'm just passing them along here. This is going to be a short tutorial, isn't it? Cool. Where's our func3? And then it's just some calculation. So look, what's going to happen? Yeah, that's the only thing I have to do sometimes, is this. I think if I type for a little bit too long and leave it, it just stops working. For some reason, it's happy. Don't know why. Why are you happy? You should definitely not be happy. Because there is no func3. Unless... No. Just happy, aren't you? It's just that I don't mind. I'll work regardless. There we go. Now we've got an error. Somewhere else. Oh, here. Ah, that's why. This is old chestnut. Cool. Then here we'll say func3. And then what do we want to do? Yeah, there we go. Do that. Happy. Now what's not happy? Oh, it's not going to show me, is it? I have to click it. Could match expected type result. Can't be because of that. No, of course not. Oh, I've lost it. Well, I mean it's pseudocode anyway, so env. Yeah, result plus. Don't do this. Doc. There we go. What's the error then? Couldn't match expected type with actual type. Oh, int with actual type. Oh yeah, look, it's up here. That might help, mightn't it? Okay, it works now. Okay, so let's pretend that this is our function, and then, I mean, we can see what it's doing. Like I was explaining when I was typing it, it's essentially passing our environment around. Yeah. So we can see from the very beginning, we're going, okay, well, our func1, pass the environment. And then this, again, we've got our environment here. We pass it to func2. From func2, we pass it to func3. Func3 will take an environment. It will return a double, so that would be happy. And then our load environment is where it's going to grab the original environment from here and then get us the environment value, which I assume is going to be environment type of this. Yeah. I'd guess if it's grabbing it from a file or whatever. Yeah, that's probably why it's not there, because then you got to like decode some JSON and do all sorts of crazy stuff, which is probably not what you want to do. So the only function actually using the environment is func3. Yeah, so that's the problem, isn't it? If we look at it, we've passed the environment around. You know, we've gone environment as an input, but look, it's not used, not used in here. It's just passed along, and then, so that's a bit annoying. It's an unpure function. So, however, func3 is an impure function. This means it cannot directly call load env an impure function. Okay, this means the environment has to be passed through a variable as a variable to the other functions just so they can ultimately pass it to function 3. In a language like with global variables, we could save env as a global value in main, then func could access it directly. There would be no need to have parameters to func1 and 2 in larger programs. These pass-through variables can cause a lot of headaches. Yeah, I've been there. I mean, you get like slightly different versions of that, but yeah, to pass an environment around like that, that'd be painful, wouldn't it? So the reader solution. The reader monad solves this problem. It effectively creates a global read-only value of specified type. All functions within the monad can read the type. Yep. So once you're in this monad, you've got the ability to read it. So let's look at how the reader monad changes the shape of our code. Our functions no longer need the environment as an explicit parameter, as they can access it through the monad. Okay, so let's have a look at, I won't type these out because we can just look at it here, can't we? So again, so the only thing that's different, if we put it up side by side, there, you see how we're running reader on func1 in environment. Okay, so let's have a look at, so then the types, they're also different. So look, this is the same, that's the same. There. Now here we're saying, let's compare it. So here we're saying it's an environment and a string, but here we're inside the reader, which is an environment and a string. Okay? I mean, yeah. If it doesn't make sense, ask me, because, yeah, well, it does to me, but just in case. So, if we look at here, so let's have a look. So it's doing func2, and then it's left binding to get our result. So what's func2? So func2 is the same. It's another. And then what does this do? It doesn't ask. Don't ask what that means. Yeah, which is a similar, which I guess it'd ask, and it gets the environment. Let's have a look. And then func3, yeah. So an ask is part of the reader, and it basically asks to get whatever value we've got in it, which for us is always an environment. So that would essentially return you this, but whatever happens to be in it, which I guess, do we even fill it up? No, we don't even fill it at this. Where do we grab it? I guess it's saying that here's where we'd fill it. Okay, and then yeah, so then it's just saying go to func3, and then you can pass it. That's just still there we're still just passing a function. So this one's not in the reader monad, but these ones are, and then that can just straight grab it. Same, because you're in the reader monad here, that's why we can do func2 just on its own. You see, because that's literally, we're just grabbing whatever this returns here. So this will return a reader event, you see, and then when we grab it, that response is just going to be an integer. You know, once we've grabbed it out of the monad, that would be an integer. And then here, that's why it has to do show, because we've got to show the integer. So is my microphone's still on. I was just double checking. So the ask function unwraps the environment. Yeah. So it just goes, take it out. So we can use it. So we can use it. The monad bind action allows us to glue different reader actions together. Literally, you have to do it twice. In order to call the reader action from pure code, all we need to do is call the run reader. Does it set you up with run? It doesn't show you how you create them. Okay, that's a shame. That's kind of interesting. And supply the environment as a parameter. All functions within the action will be able to treat it as a global variable. Okay. It might not seem like we've accomplished much, but our code is much more intuitive now. We keep function 3 as it was. It makes sense to describe it as a function from an environment to a value. However, our other two functions no longer take the environment as explicit parameters. They simply exist in a context where the environment is a global variable. Okay? So accumulate values. What? Oh, okay. Oh, I'm time over. I am time over. So we know we've got to there though. Let's just make a. Let me actually. Yeah. So we've got to here. I'm gonna have to do that. Yeah. Got to there. Save it. Yeah. So because if I keep going, I'm already like gone over. You know, you can't be on here all day, can you? Though it's kind of fun. You can't just keep going. Cool. Okay, so I'm going to stop there. So we've got to. What I'll do is, if anyone's interested in carrying on, there it is. Yeah, and what I'll do, you know, for lols. There we go. That's I don't know why I just did that. Absolutely no reason. But that's the end of the stream for today. What is it? Friday tomorrow. Yeah, I might. I really need to get a schedule going, so I'm like a bit more regular, so then people know when to come. But normally, it's around UK time, sort of 4 or 5. I don't know. It's like in the evenings UK time. I kind of aim for, and whatever day. So yeah, basically, I've just made it more confusing. That's what I've done. But there you go. Cool. Well, thanks for joining along. And yeah, I'll send out messages whenever I'm back online, or if you follow, I guess. Yeah, then you'll get told, won't you? Do you? I think you get sent an email, don't you, when I'm about to go online or something. Well, actually, that probably only works if I if I set up a schedule, which I haven't. So yeah, just hope come to the channel. I might be there, might not. That's basically it. You know, like catching the wind. Cool. All right. Well, thank you very much. And I'll go back to this screen and I'll except it says stream starting, which isn't very intuitive, but I'll say bye for now anyway. See ya.